We designed the CABLEBOT as a tool to observe the farms. Do the work that we cannot do every day, to observe and recollect images and information about the plants. So we can use those images later to understand what's happening with our plants, with our farms, with our crops. The simplest path we arrived to get a camera and an image capturing device to move in our farm, and the cheapest one, is just hang a cable and put a robot on top of that cable in a way that it can move automatically by himself. Whenever you schedule him to get pictures, he will just wake up, go ahead, take photographs of the farm, and come back and upload those photographs to a server so you can process them and go to his home and be safe of the environment, right? That offers a lot of challenges that we faced, like types of cables, the length of the cables, how fast do you need to move, I'm vibrating and my images are not good, etc. So we face this with the limitations of trying to build a robot that's replicable by anyone, that can be done with all the free tools that we just taught. And we tried to solve it with 3D printed pieces. We choose construction material that's aluminum with plastic that we can mill and CNC in any cheap CNC. We choose almost commercial components like screws, like springs, like stuff like that. So all these devices can be built easily by anyone. A robot that hangs on cables faces different challenges. One of the biggest challenges is the tension of the cable that varies depending on the length of the cable, the type of cable, and the type of installation. So we designed a spring system that allows the robot to come up and down, adjusting and adapting to the tension. Okay, you can see it here also. That's designed since digitally here, and all the pieces are inside here. Okay. The more heavy part of the CABLEBOT is as closer as we can to the center of gravity, close to the cable. So we have a brushless motor here that's controlled by some electronics that need to be in the back of the CABLEBOT. We have this kind of wings that hold the CABLEBOT against the cable with a couple of pulleys, and inside all these parts we have all the electronics designed specifically to fit those wings. You can see here this that seems to be uncabled, but it is cabled. All the cables are inside. Everything is cabled here, with exception of the motor that we're doing some tests right now, and with exception of this that we are using it to prototype right now. We have a power module on the bottom that with 2 screws you can remove completely and interchange it by another one. Why did we did this? Because the idea is that accessibility to batteries is different depending on the place and depending on the time. So this is a module that you can replace with a different technology. Maybe in your area you cannot use lithium batteries because they are not accessible. So you can use another type of batteries and change the design of the CABLEBOT from here to the bottom. No? After the battery in the bottom, we have the camera module. This camera module, the idea is that's not only for this guy. This can be used in any of the other robots of the ROMI project or in any type of free development. So this is just basically a device that has enough electronic brains to control this device, to order him to move and go there. And once he is where he wants, he can take pictures and align himself to the proper orientation. He can also correct vibrations on real time. So if the CABLEBOT is vibrating because there's too much wind, or the cable is too long and you are vibrating, then you can correct that with the camera module. We also have here another brushless motor that controls this movement and is controlled by himself. So as you can see, it's a complex system. We have different controllers and different drivers for mechanical parts, motor parts, etc., and also optics here. No? All of those have a software interface that allow them to communicate in a transparent way, in a way that they can also communicate with the servers, and with the same servers that the other robots communicate. So you can share all the information between the different parts of the system. And also we are trying to keep all the development in terms of libraries aligned in a way that we can use exactly the same protocols and standards here than we do in the rover, than we do in the plant scanner, etc. The modeling and the robot is built with open source and free tools, and we build free designs, but also electronics. No? The electronics are designed in-house, and we also use open source and free tools to build them, in this case KiCad, and we produce them. Right now it's just prototypes, but we publish all the designs so anyone can produce them by themselves. No? We try to keep it as simple as we can, and we use commercial products that are built by companies that are committed to free hardware also, in a way that you can, even if this company stops producing that specific board, you can find replacements or build your own, or change your own. So in the case of the CABLEBOT, we have three main boards. One is the board that holds the brain of the camera module, that controls the orientation of the camera, takes pictures, and also sends communication in terms of position to the board that controls motors and stops and is aware of the geoposition of the robot. And at the end, we have a very simple power distribution board to take care of fuses, of trying to save all the parts of the CABLEBOT from problems with power and distribution of power from the battery module.
Sí. Listo.